Good afternoon, Engineer Abdul Basit. Good afternoon, all. Have a good evening already. Thank you for joining. Confirm you can hear me, please. Programs chair, sir. Good evening. Welcome.
Yeah, thank you. Can you hear me?
Loud and clear, sir. You can hear you.
Excellent. Well done, eh? Well done.
So we'll allow some time for people to join. Madam Tessie, please, can you allow me to share my screen? Section chair, welcome, sir. Good evening.
Mr. Bashar. Mr.
Yes,
Bashar.
sir.
Okay, good. So this is 7 minutes. What's our plan or forum and time to kick off?
Okay. We wanted to allow for a little bit time, maybe 5:10, so that
Okay.
other people can join. And at the back end, we
Okay.
are reminding people to join.
Okay. Excellent.
Yes, sir.
Excellent. Thank you. Thanks.
Thank you. So the section chair has joined. I don't know if he can hear us.
Hello, Bashar. Well done.
Thank you, sir. Good evening.
Section Chair, good evening, sir.
My God, well done, sir.
Well done, eh? I thought you
Our
had done.
meeting on family today must hold, though. Even though I was waiting yesterday, but I think I made a mistake. I should have been the one to call. So today
No,
on family, I'm going to make sure
it's,
I call you.
don't
I
mind me.
only
It's
call
not.
you to let you know if you're available. So I will initiate the
Yeah,
call.
yeah,
Yes.
don't mind me. What happened was that it's actually my system. My system had problem. I've been trying to
Oh,
work around it in my ICT. So I
oh,
needed my
okay.
laptop. So most times what I do is with my phone and it's a
Oh,
bit
okay. Oh, okay.
convenient. So I want a situation where we
Oh,
can. So
okay.
hopefully by tomorrow, I should have been
Okay.
sorted out. Uh,
Okay. Okay. Then I'll wait. No
okay, sir.
problem.
All right,
All
sir.
right, sir.
Thank you, sir. Yes,
Okay.
sir. Mm.
Thank you.
Uh, uh,
Okay. Okay. Program chairs, section chair, distinguished lecturer, and participants that have joined this call, good evening. Confirm you can hear me, please, and as well see my screen.
Yeah, we can hear you. We can hear you very well.
we can.
Yeah. Okay. I think we've allowed more time for people to join. Our time is far spent, so with your kind permission, sir, I think we should just progress with the session.
Yes, please. Let's go ahead. I think this is fine. We're
Yes.
good to go. Yeah.
Okay. So this is the agenda. I don't know if my screen is changing. I'm having some glitches. You have the agenda displayed. Confirm you can see that.
Can't see the agenda yet. Was just in the.
Let me share the screen. Okay. Confirm you can see it now.
Yes, please.
All right. Thank you. So this is the agenda for today. We'll take the opening prayer, safety brief, welcome address, opening remarks. Then we'll hear from the presenter. Then take some, have some interactive session Q&A. Then we have the takeaways and then the closing remarks by the section chair, which will close this program proper. So we crave your indulgence and your participation, please. Thank you. Can we all unmute our mics to take the opening prayer, which is the third stanza of the Nigerian national anthem, please, after the count of 2. 1, 2, go. O God of creation, direct our noble cause, guide our leaders right, help our youth the truth to know, in love and honesty to grow, a living just and true, great lofty heights attain to build a nation where peace and justice shall reign. Amen. The next item is the safety brief. Anthony, please kindly unmute and take the safety moment.
Yeah, I can hear you.
Yeah, you have the floor for safety brief. 3 minutes, please. Thank you.
Everybody this evening, okay. Can you hear me? Confirm that you can hear me. Confirm that you can hear me.
Yes, we can hear you. Go ahead.
All right. Okay, you're welcome. My name is Odige Anthony. Now is the safety brief for today's meeting. Let's listen and adhere to it. Ensure you are not too close to your phone or your laptop screen to prevent you from vision syndrome. Make sure you are hydrated as we are about to kickstart the meaningful lecture, or you can keep your water close by. If you are in a noisy place, try and look for a serene environment where there will be less or no noise to be able to listen attentively. For orderliness, make sure you raise your hands or use any of these emojis on the Zoom options during questions or contribution. If you are on transit, stay as distractions to us all. And the comment box is always open. Drop them there and the moderator would read them when necessary. Once again, I want to thank every of you who are online to listen to this show, and I believe that you won't regret it. Thank you so much. Thank you, Mr. Kash.
Thank you very much, Engineer Anthony, for this app safety brief, for reminding us how to take care of ourselves and while joining this session, and as well in our day-to-day activities by staying hydrated. Thank you. The next item is the welcome remarks or welcome address, which will be taken by our program's chair in person of Engineer Elvis. Engineer Elvis, sir, you have the floor. Thank you.
Yeah, thank you very much. Good evening, everyone. Section Chair, good evening. I want to respect every dignitaries, our directors, and our highly esteemed lecturer of the day that will be making this presentation. I really appreciate you, Engineer Abdul Basit Usman. Thank you. You're welcome. The technical lecture for October. Generally, this is a platform and forum for us in SPE to interact on ongoing activities, knowledge, ideas, innovations, particularly within the oil and gas, the energy, and other fields. So knowledge is very, very important. Any day you stop growing, you stop learning, that day you start dying. So this is a great platform for us to come and enhance on what you know, or you learn something new. We're actually living in a world that is changing, is dynamic. You sleep today, you wake up in the morning, what you know, the theories, hypotheses, beliefs you have are already changing. So in order to stay at pace with the growing trends, remaining strong, agile, we must be open to knowledge. And I guess that is why the SPE, Section 104, has deemed it fit that every month we're going to be having technical lectures, distinguished lectures, and other forums where we'll continue to share ideas. So today, I want every one of us to relax and listen to this promising technical lecture on hybrid anchors for deep water. So I hope at the end of the day, we'll all be very happy to have learned one or two things. So thank you very much as we progress. Thanks.
Thank you very much, Programs Chair, for this welcome address. Without further ado, we'll invite the section chair for his opening remarks. Section chairs are Dr. Oluwaseun Adetona. You have the floor. Thank you.
Hello, Bashir. Am I supposed to be talking now? You want me to come on?
Yes, sir. Yes, sir. Come.
Oh, okay. Because I'm not actually seeing your screen. It's okay. Good
Yeah.
afternoon, everyone. Or good evening, everyone. It's good to be on this call. This is another technical section series, and we are happy and impressed to have a technical expert to come and give us detailed information about a technical aspect of our field, which is very critical to the survival of the oil and gas industry and for our technical know-how. So I would like to indulge our students, our young professionals, our professionals, to listen attentively to the presenter, because some of the things we learn here is part of the reason why the objective of SPE is to connect us professionally, technically, and to make sure that we have a detailed knowledge of every aspect, every area of the industry. So as we sit tight with our laptops and with our phones, I would like to appeal to us, please do not leave the call. Let's listen, ask questions when the presenter has finished his call. And at this point, I would like to also thank the presenter for taking the time out, preparing the slide, and getting ready for us so that we can have a very sound presentation today. So at this point, I would like to thank the program committee for being able to achieve this and ensuring that the presentation is actually coming to life. Thank you all, and have a pleasant and a wonderful time out during this presentation. Thank you. Hello, Bashir, did you hear me?
Yes, Section Chair, we heard you. Thank you. It was loud and clear.
Yes, sir. Thank you very much for the opening remarks. That's the section chair in person of Dr. Oluwaseun Adetona. Moving on to the next item on the agenda, which is the introduction of the speaker. Okay. Abdulbasit Usman Isa is a dedicated civil engineering professional specializing in offshore structures and geotechnical engineering. He earned his MSc from the University of Southampton last year, where he conducted in-depth research on coastal structures and offshore geotechnical engineering. His academic excellence was recognized with the prestigious University of Southampton Presidential Scholarship, which fully funded his MSc alongside multiple scholarships from the oil and gas industry, including those from SPDC, Chevron, and Total, which supported his undergraduate studies. As a full-fledged member of esteemed organizations such as the American Society of Civil Engineers, the Institution of Civil Engineering, the Institution of Civil Engineers, and the Nigerian Society of Engineers, Abdul Basit demonstrates a strong commitment to professional excellence, and he is now currently employed with the Nigerian National Oil Company, NNPC Limited, where his contributions are highly valued. Join me, ladies and gentlemen, in welcoming our esteemed guest lecturer, Engineer Abdul Basit Usman, to the mic, where he takes us through his presentation. Engineer, good evening. Welcome. Engineer Abdul Basit, if you are speaking, you might be speaking on a muted mic.
Can you hear me?
Yes, loud and clear. Go
Okay.
ahead.
Thank you very much for this opportunity. Thank you to the organizers. I really appreciate the opportunity to share this knowledge with all of us.
Engineer, do you want to share your screen or you want us to project from our end?
Okay, I think you can project from your hand.
Okay.
Okay, thank you. Okay, please confirm you can hear me.
Yes, please, go ahead.
All right. So today I will be taking us through hybrid anchors for deep water tension leg platforms, how we enhance the resistance with gravity-assisted suction caisson. Okay, next slide, please. The lecture overview include the introduction to tension leg platforms, where we'll talk about what tension leg platforms are, the anchoring challenges, hybrid anchors, that's the concept as well as the design, gravity-assisted suction caisson, which is a type of hybrid anchor, applications, and industrial impact. And lastly, the conclusion and question and answers. Okay, introducing tension leg platform. Why tension leg platform matters? Tension leg platform is used in deep waters. That is due to the high demand for renewable energy, which is part of the Global Sustainability Program. There is this trend of moving into the deeper parts of the water, especially for floating offshore wind turbines. And also the prospect of getting valuable oil reserves, so we have to set up the tension leg platform in deep waters, which range from 500 to 2,000 meters in depth. So it's mostly used in oil and gas and offshore wind turbine. And also it's usually in a challenging environment. I don't know, I have a YouTube video I would like to share with us, if it's possible for me to do that.
Yes, I think you have permission to share your screen. Go ahead.
Oh, okay. I think you will need to stop sharing temporarily. Just a minute.
Okay.
Okay, can you see my screen?
Yes, please.
All right, all right. All right. So let's have a look at this. Looking at this video here, we will have an idea of the kind of tension, wind, tidal wave that the tension leg is subjected to in deep water. So this is just a video from YouTube to give us an idea. Okay, Bashir, I would like to stop sharing this now
You can
because of
continue.
time.
You can continue sharing. It's okay. With your
All right.
presentation, rather.
Okay, 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 I will do that. Okay. Okay, kindly confirm if you can see my slides. Please confirm you could see my slides.
Yes.
Oh, thank you. Good. So the key challenges with this particular tension leg platform. Okay, on this slide here, on the right-hand corner, just down here, we have a schematic diagram of the tension leg platform, which shows a simple wind turbine. This is the frame structure of the tension leg platform. This here is the mooring line. And then this is just a schematic representation of the suction caisson, which serves as the anchor, as a traditional anchor for this particular tension leg platform. So the main problem and the challenges we do face when installing this in deep offshore waters is the soft seabed. And then most time we do have seabed with a lot of layers with a densely consolidated clay, which lead to high cost of anchorage, where we have, which exceed about $100 million. So based on this, I did a research on how to combine the best properties of existing anchors to come up with a hybrid anchor, which is much more efficient as well as cost effective. So introducing you to type of anchors, we have different kind of type of anchors. We have the plate anchor, and the mechanism is drag embedment. We have the driven pile. We have the suction pile. Also, we have the gravity anchor. So the concept of this is to pick the best properties of existing anchors and combine it to have a super hybrid anchor. So in this case, a suction caisson plus the gravity mass anchor. As put as written here, the benefit is higher resistance, lower cost, adaptable to seabed conditions. Here, over here on the right side of this slide, we have the schematic diagram of the hybrid anchor. This is the gravity anchor, which is a bit shaded in gray. And then here is the suction caisson. And then we also have the seabed adequately represented here. So as shown in the video, that's on the YouTube video, right? When tension-led platform is installed in deep waters around the depth of 500 to 2,000 meters, it is being subjected to load, which is being transmitted through the mooring line to the anchors. These loads are generated from the tides, the waves, and the winds. So in the oil and gas application, I know the tension-led platform supports the rigs. So, and they're also subjected to similar weights. So looking at this schematic graph here, it shows how the tension varies on the mooring line. That is this line here. Please, are you with me?
Yes,
Hello?
we are. We are.
Okay, thank you. So this particular mooring line, which I am pointing to here with the laser, is being subjected to tension due to these tidal waves, winds, tides, waves, and winds. So taking the daily reading of this particular load, we have it in a cyclic form. So by the time you take the average of this load, we call it the static load. And anything above the average, we consider it as dynamic loading. So the total tension or force experienced by the mooring line is the summation of the static load plus the dynamic loading. So this is very useful in the design of hybrid anchors, So when we reflect back on the initial challenges, which is soft sea soil and presence of several thick, dense layer of clay, which make it very difficult for us to install a suction caisson, which has a very long length. So by the time when we consider the hybrid anchor, that is what we consider the best properties of gravity anchor and that of the suction caisson, we will need to consider the static load and the dynamic load. So looking at this particular schematic diagram, the static load is higher than the dynamic load. So when we are designing the anchors to be used in the hybrid anchor, when we give this static load to the gravity anchor, it saves us a lot of problem because the remaining dynamic load is just small, is little, and when you design for that, the total length required, the total embedment required in the seabed is just little, like it's not that much. Okay, let's go. Yeah, this is a clear depiction of the hybrid anchor and also its resisting capacity. That's for the suction caisson. It resists the tensile force, that's the pulling force exerted on it, this particular force exerted on it by the mooring line through the steam friction and reverse end bearing. For those who are in civil engineering, I know they are familiar with pile foundations, which are used for high-rise building. So, but for high-rise building, it's usually the end bearing. But in this case, for suction caisson, we have the reverse end bearing, which is being calculated with these formulas. While the resistance of the gravity anchor is calculated using the buoyant weight. The buoyant weight of the gravity anchor times the volume. So looking at this, what are the hybrid anchor? The suction casing enhanced with gravity mass, and how they work. They work by increasing the resistance capacity of the hybrid anchor. The advantage for this is the better resistance to cyclic load in soft soils. Okay, so we have discussed about the concept of the hybrid anchor and how it is being applicable to anchor a tension leg platform. Now, after conceptualizing the idea, the next thing is to carry out a numerical analysis of the idea to see how feasible it is. So any finite element software can carry out this analysis. But for this particular one on this slide, the software is Plaxis 2D, which is a finite element software used for analyzing the soil structure interaction for offshore structures. So analyzing this hybrid anchor, here is a simple flow chart of how it is done. So by the time you have the numerical model, the first thing you do is to carry out unconsolidated on-drain analysis. Apologies to those who are not in the civil engineering field. So the unconsolidated on-drain analysis is simply the analysis carried out instantaneously. That is, after assembling the hybrid anchor, that is by installing the suction casing and placing the ballast load on it, then you carry out your analysis. That is, you put the mooring line and pull it up. So after pulling it up, you'll be able to determine the anchor tensile loading. That is the resistance of that particular setup, that is this setup, instantaneously. Whereas for the consolidated on-drain analysis, is the analysis where you assemble the hybrid anchor setup. That is, you install the suction casing, you place the ballast load on it, and then you allow it to remain there at different time interval. You could take a month, 2 months, 3 months, 1 year, 2 years, up to 28 years, which is the lifespan of most of the offshore structure. And then after that, you pull it up to know the anchor tensile resistance. And that's when we have the consolidated resistance. Also, we also check the soil properties, that's the geotechnical properties after this duration of time. So this is what this chart here is all about. Then on this side, this is a simple schematic arrangement of the hybrid anchor. And then this here is the model, that's the numerical model representing this particular anchor. You can see that it's just half of it that was modeled. It is perfectly symmetrical because suction casing is circular. This gravity anchor here is also a circle when you look at it from the plan. So we only model half of it due to computational effects. That's to have an accurate result. So by the time you look at the finite element model of it, you have this particular output. So we have this is the mesh, and this is the refined mesh of it. So this is used to carry out this particular chart here. So this is the entire procedure for the analysis, while this is how the model looks like. So the performances and the benefits of hybrid anchor. After carrying out the analysis, you realize that there is an enhanced load resistance, which is about 20 to 30% more resistant than the traditional anchor. This is adequately represented on this chart here. On the left side, on the right-hand side bottom here. So on this chart, we can see the green line. We can see the light blue line, right? The green line represents the traditional suction caisson. That's the resistance offered by the suction caisson. This particular light blue shows the resistance offered by the gravity anchor. So we now have the total resistance, which is this black line. And then the total resistance offered by the Plaxis software, that is the numerical software. And then, you know, as the rule of thumb, we always checkmate the numerical analysis with analytical results. So this orange line shows the analytical results by combining the resistance of the suction caisson and the ballast. So what this means is that by increasing the diameter of the gravity anchor, the ability of the hybrid anchor to resist the pulling force from the mooring line, which is caused by the wave as well as the tide, as well as the wind effect, is increasing. So by the time you increase the diameter of the gravity anchor, the entire capacity of the hybrid anchor, which consists of the gravity anchor as well as the suction caisson, increases. So that's that about this particular chart over here. So let's come back here. So we have the tensile resistance, which I've explained earlier. It increases. The ballast load effect on geotechnical properties. Okay, so by the time you place this particular ballast on the subsoil located at the bottom of the sea, there is instantaneous dissipation of water and reduction of the void ratio around the soil surrounding this particular suction caisson. So this is the base of the sea. Sorry, are you with me?
Yeah, yes, sir. Just go ahead. I think it's a mistake.
Okay, okay. So for this particular configuration of hybrid anchor, when you place this gravity anchor on top of the suction caisson, due to the soft nature of the seabed, that is the soil in the seabed, there will be a compression. This compression leads to dissipation of water as well as the void ratio. So based on this, there are changes in the geotechnical properties of the soil surrounding the hybrid anchor, which leads to improved resistance of the hybrid anchor. And lastly, also, when this particular gravity anchor rests on this particular soil that's surrounding the hybrid anchor, the soil surrounding the hybrid anchor for a number of years, there is a long-term consolidation, which also improves the resistance of this hybrid anchor. So the cumulation of this tensile resistance due to the additional weight of the gravity anchor, the ballast load effect, and the consolidation give us about 20 to 30% more resistance compared to a traditional anchor. So that's that about this particular tile. So talking about this and the performance benefit, that's the stability in subsoil. So it's just by compacting the soil and making it much more stable. So we now talk about the economic and environmental impact. So hybrid anchor reduce the anchor counts. That is, for a traditional anchor, due to the high cost and also the issues we have while installing it offshore. Due to the dense clay layer, we cannot achieve the design lengths desired. So we'll end up putting a number of traditional anchor. Maybe for a particular design, we need like 10 meter of traditional anchor. But when we got to the site, we now discovered that there are a lot of dense layer of clay which cannot be penetrated. So what we'll do is to increase the number of traditional anchor. But however, with the concept of this hybrid anchor, instead of increasing the number of traditional anchor, we introduce a ballast, which will end up offsetting the remaining resistance required. So by doing so, it lowers the capex by 10 to 20%. So also another advantage of this is the smaller seabed footprint. So it is also easier to decommission. And lastly, it supports renewable energy. That's offshore wind turbine program currently going on in developed countries. In conclusion, hybrid anchors enhance tension leg platform stability and reduce costs. Gravity-assisted tension are a game changer for deep water, broad applications in energy and sustainability, as explained earlier. So the call to action, explore hybrid anchor for your next deep water project. Thank you very much.
Wow. Thank you very much, engineer, for that wonderful presentation and keeping to time. You've made us understand that hybrid anchors offers a practical pathway to more resilient, cost-effective, and sustainable offshore foundation systems. I like the fact that it addresses the issue of sustainability. It's not just about the anchorage of the oil and gas production platforms, but it also can be used for wind turbines for renewable energies as well. That's a very good one. Colleagues, ladies and gentlemen, senior colleagues, I think we heard from Engineer Abdul Basit. It's now time for comments as well as question and answer session. If there's any clarifications needed or maybe something the engineer said and somebody's not in agreement with, you can come forward and challenge it for our learning sake. And engineer, apology not accepted. Earlier you said apologies for the non-civil engineers. Well, you didn't apologize for the non-engineers at all. You only apologize for those that are not civil related. Anyway, that's on a lighter note. Thank you.
Yeah, thank you.
Yeah. So I cannot see any hand up. Basically, what you have said, everybody must have understood. Well, let me just throw this question to you, engineer, before somebody will come up. I understood that this is like a research that you've conducted, right?
Yes.
Okay, so my question is more of in terms of future outlook of such research. What future research areas could further improve hybrid anchor design and predictability? as well as I have a question in terms of the safety assurance in adopting hybrid anchors for deep water usage. How safe it is? Basically, when we see cost effectiveness, some people will be worried whether with the reduction of cost also comes with reduction of quality or particular standard. So, can you give us some clarification that with the hybrid anchors, the safety is not compromised, and as well as the predictability of the features designs. Thank you.
Oh, thank you for the question. Regarding the future outlook, combining other kind of anchors with suction casing, such as the plate anchor with suction casing, and evaluating the combined resistance is one possible way to also research on this, especially when you look at the drawback of gravity anchor. Now, in as much as gravity anchor assists the suction casing in the soft offshore soil, all right? When you place the gravity anchor on the soil, there is high tendency of it sinking into the soil or tilting and causing problem. So looking at other type of anchors, such as the plate anchor, which uses its drag effect to generate resistance, is a good area to also research. Concerning safety, all of these anchors that are being combined, that is, the best properties are being combined together to produce an hybrid anchor, have been in use for years and they are safe. So what this particular concept does is to pick the best properties of the existing anchors and look for a way to merge them together. So in addition to future outlook, we could also research on appropriate ways to connect the gravity anchor to the suction casing. That is the design of a suitable connection so as to ensure monolithic resistance. That is, when you place the gravity anchor on the suction casing, how do you connect it for effective combined resistance? Because this is just theoretical. We assume that when you place it, automatically, both the gravity and the suction casing help to resist the load caused by the wind as well as the wave. But however, there is a huge research gap in between where you have to consider various kind of research connections that can be done to ensure effective load transfer. Thank you.
Oh, wow. Well, thank you very much, engineer, for that response. We have a hand up. Engineer Dolapo, kindly unmute and take your comment or question. Thank you.
All right, Engineer Bashir, thank you very much. Good evening, everyone. And many thanks to our presenter for today for introducing us to this new concept. So I have two questions, and I think maybe in the course of the presentation, you must have talked about them, but I just needed to shed more light. And the first one is on the cost effectiveness of these technology. I don't know if you are able to shed more light in the presentation. I know you say it's more of research at this moment, but if there's something you can just say to enlighten us on how effective it is cost-wise, that would be nice. And the second one is for existing structures, is it adaptable with existing structures or is it just for new offshore structures? I must have missed that, but if you can graciously talk about this, that would be nice. Thank you.
Okay, thank you, Dolapo, for this question. Regarding the cost effectiveness, yes, I will shed that light on that in two directions. That is, the first one is the traditional anchor suction casing works on the principle of skin friction as well as reverse end bearing. To explain this in a lay term, when you carry a cup, a tumbler, that's glass cup, and you place it in your mouth and then you suction it, like the cup sticks to your mouth. That's simply the principle of suction casing. So after a while, it starts to lose its function, which leads to failure. And imagine you install something offshore, subjected to wind load, tidal loads, huge waves, and then your anchor loses its suction and it collapses. That's a huge loss of capex and all the opex. So when you now adopt this measure of gravity anchor plus suction casing, automatically gravity anchor doesn't have any suction. Whatever you design for is what it is for the next 28 years. So by the time you do that, you know that, okay, your facility is safe out there. So it is now saving you the cost of losing your investment. That's the first direction. And then the second one is the seabed now is a kind of, what is it called? It has different properties all around. That is, the property underneath the seabed varies. So sometimes while trying to install a suction casing of a design of a specific length, you encounter maybe bedrock or a highly dense clay, which will prevent you from using the normal technique to install this suction casing. So this will involve additional cost of logistics, bringing special equipment to now install this suction casing. So by the time you now adopt this particular hybrid anchor design, you save the cost of doing this additional logistics and needing specialized team to install your traditional suction casing. I hope this answered the question regarding the cost. Sorry, the second question skipped my mind. Can you come again?
Yeah, okay. Yeah, thanks for answering the first question. So the second question is if it's adaptable, compatible with existing structure, or it has to be something that has to be installed at the commencement of a new structure.
Oh, yes, it is compatible with existing structures. That is, for existing rigs, floating wind turbines, and offshore structures that are using tension-leg platform. In as much as it is tension-leg platform, that is, the mooring lines are tensed. Yeah, it can be installed and it's compatible. Yes.
All right, thank you very much.
Okay, you're welcome.
Thank you very much, Engineer Dolapo, for the question and our presenter for graciously answering them. I cannot see any other hand. Okay. Kozim Oluwokere, apologies if I didn't pronounce the name well. You can go ahead. Thank you. Loud and clear.
Okay, thank you. Thank you to presenter for today. And yeah, interesting topic to discuss. So my question is about the suction and the gravity. Can it be reversed in such that the gravity will be below while suction will be above? And if that is possible, how are we going to achieve the bonding between these two elements? I don't know if that question, if you get it right.
Okay, thank you for the question. I don't know if Mr. Bashir can rephrase the question clearly because your network was not so clear.
Okay, confirm you can hear me now.
Yes, I can hear you.
So my question was that can the arrangement between the suction and gravity, if you have a suction and gravity arrangement, can it be reversed?
Okay.
When you presented, I could see that the gravity is on top while suction is below. Is that
Yes.
correct? So can it
Yes.
be reversed such that the gravity will be on the seabed while the caisson will be up? And a follow-up question is, if that is possible, how are we going to achieve the bonding between the two elements in that gap, given that when the suction is inverted, part of the force, the resistance is being provided by the water in the caisson. So, but if it is reversed, how are we going to achieve that bonding?
Okay. Thank you for the question. So it's like the first question is the second question is dependent on the first one. So your question, if I get you clearly, was can the gravity anchor be placed on the seabed first before the suction caisson on top of it, right?
Yes.
No. I think it will totally change the whole thing then. That is, the gravity anchor is no longer assisting the suction caisson. So, but answering your question directly, I don't think it will work that way because the suction caisson work on the principle of reverse end bearing as well as skin friction. That is, when you insert the suction caisson, which is a huge something like a cylinder, a very big cylinder that is long, you insert it inside the soil, and then you now suction just the way you put a tumbler in your mouth and suck out the air, and then it sticks to your mouth. So when you do that, then the things that provide the resistance or what make it to stick into the soil is the reverse end bearing, and then that friction it have with the soil surrounding around the skirt of it, that's the side of the suction caisson. So you see, by the time we put the suction caisson on the gravity anchor, it won't have any resistance, and then it will not be useful in the whole system of hybrid anchor.
All right. Okay. Thank you so much.
Okay, thank you.
Okay, thank you very much for the wonderful question and the nice and apt response. I believe all the hands have been honored. We'll quickly move to the next item on the agenda, which is the key takeaways from the presentation. And then we'll have a vote of thanks from Prof. Juliet. Then we'll take a closing remark from the section chair. Okay, before that, we'll now have a photograph session, please. So, guys, arrange yourself well. If you want to wear your cap, do that in anticipation of the photograph session. Thank you. So, from my own, what I've jotted, the key takeaways are: one, understanding hybrid anchors. The presenter adequately explained how hybrid anchors combine suction caisson and gravity ballast mechanism to deliver superior holding capacity under continuous tensile loading. Also, we also can get the understanding of the soil strength and consolidation. That is ballast loading. It promotes pore pressure dissipation and reduces void ratio, resulting in increased undrained shear strength and improved soil behavior around the anchor. So in terms of the performance and reliability gains, there are numerical simulations which indicate hybrid anchors outperform conventional suction caissons in both short and long-term performance scenarios. In terms of the economic and environmental advantages, the hybrid anchors are indicates reduced material requirements and enhanced durability, lower installation costs, and environmental disturbance in deep water projects. So that is it from me as what I've jotted for the key takeaways from this presentation. I know you guys also have jotted down some takeaways from this session. Once again, we thank you for your participation and thank the presenter for finding time to share this with us. The next item on the agenda, which is the vote of thanks, we'll invite Prof for her vote of thanks. Prof Ma, kindly unmute and help us with the vote of thanks. Thank you for...
Okay, good evening, everyone. Can you hear me?
Yes, ma, we can hear you. Good evening.
Good evening. Also, thank you so much for this chapter. I appreciate the speaker. Thank you for doing justice to this topic today. Hybrid anchors for deep water TLPs, enhancing resistance with gravity assisted suction questions. So thank you so much. We appreciate you for doing this. I will thank your company too, NFPC, for giving you the permission to present this. Thank you so much. God bless you. Then we appreciate the program chair for putting this together. Thank you, Session 104. I appreciate you for all you do for Session 104. God bless you. We appreciate every member of the team that has helped in one way or the other, the board members, to put this together. We appreciate you. Thank you so much. And the anchor for today's program, we appreciate you. Thank you. And everybody has found time to join online. Let's your busy schedule. This evening you are closed for work and all that. You find time to join this call. Session 104 appreciates you. Thank you, and keep doing this. Anytime you see our invites, our meetings coming up, please don't hesitate to join in. God bless you. Thank you so much. So that is all from my end. God bless you.
Thank you. Thank you very much, madam. Our dear Prof, always following up with our programs. The next item is we'll just take the closing remarks from the section chair. Then we now quickly have the photograph session and close. Thank you. Section chair, sir. Kindly your closing remarks.
Okay, Bashir, section chair is not on the call, but I think if Prof wouldn't mind, she can actually do that on his behalf. Thank you.
Okay, thanks for that. Prof, kindly help us close the session.
Okay. Okay, so on behalf of section chair, we appreciate this. Like when you showed that clip and all that, I can really imagine what some companies would have been facing in the deep water. And I believe giving this presentation today, we have one or two persons on the call in their company that have such challenges. So once again, we appreciate everyone, and we appreciate the program chairs seriously, because all the programs anchor him. And if he does not put this together, we will not be here. So thank you on behalf of the session chair. God bless you.
Thank you very much, Ma, for stepping in. Okay, guys, it's time. Kindly open your videos so that we'll, in 30 seconds, have our pictures. Mark your attendance, oh. So that next time, if Abdul Basit becomes a novelty winner, you'll be like, I was part of his presentation. Okay, I can see KB. All right. What of? Can you open your videos? Nice. Our engineer can see you. Prof Ma, can you please help us with your video?
My apologies, I might not be able to show my video right now. Thank you.
Okay. All right. Thank you. Yeah, accept that. All right. KB, you off your video again. Tahir. Ahem, Tony, nice one.
Hello, yes. So Bashir, good evening. Thank you very much for organizing this.
Thank you. Show your face. Aha. Nice. Okay, just give me a second. I will take another one. Engineer Ogene Fejiro. Nice one. Thank you. Perfect. All right, guys. That's it from us. Thank you for your time. Do have it. Enjoy the rest of your evening. Bye. Thank you, Programs Chair. Thank you, Prof. Thank you, Engineer Bipasi. Thank you, Fejiro. Thank you, Dolapo, for the publicity. We appreciate. Thank you, Anthony. Bye for now.